Thank you. Hello, my topic is about security of GitHub Actions and workflows. My name is Alexander. I'm a product security architect at Intel. I'm responsible for securing some AI and ML systems and applications. And if for some reason you need to train your model, you train your computer vision model fast with this nice UI, check out this repository. This is a Getty product. Everything, including source code, Helm charts, container images, are publicly available. So that was AI part of my talk, and then let's switch to security part. So the context of this topic is you have a GitHub repo, and you use this GitHub repository to maintain your project. This repo is publicly available, and you use workflows and GitHub Actions as a main engine for execute your CI/CD pipelines. And there is some concept that called IssueOps that you can use if you use GitHub. And roughly speaking, this is a way how you can, as a maintainer, how you can control execution of different workflows. So for example, you can put some specific comments under pull request, and it will trigger some workflow execution. You can assign some label to pull request or issue and it will trigger some workflow and execute some automation. And one of the common case of using this IssueOps approach is that are widely used across open source is when you need to accept pull request from fork. So the typical case, when you accept a pull request from fork, it means that by design, if your workflow is triggered with this pull request trigger, GitHub doesn't allow this workflow and jobs in this workflow to consume credentials and to get access to GitHub token with write access. So this is done because potentially any contribution from fork is untrusted, because for public available repository, everyone with GitHub account is able to make a fork, make some changes in their fork, and return back some contributions. So that's why if your workflow is triggered by pull request event, and if this is triggered by code from fork, GitHub by design doesn't provide this workflow and jobs access to credentials, to secrets, to GitHub token with write permission. But in most cases, for some reason, you would like to provide this workflow access to credentials. For example, when you accept a contribution from fork, you not only want to pass some linter checks, but also make some end-to-end test or integration test. And this test require you to pull some container from some private registry or access to some internal infrastructure, something like this. So you want, by design, to allow this workflow to touch this long-lived credential or access token. And to solve this problem, technically, you can change this pull request to pull request target event, but this will be not secure. Usually, you can say, OK, I will split my workflow into two workflows. The first workflow is unprivileged workflow. I will check out code. I will make some check that doesn't require any access to credentials, like linting, static code analysis, unit test, and other stuff. Then I will ask human to review results, or maybe you can ask some AI bot to review results. And then a reviewer on step number 3 puts some specific comments under this pull request, something like OK to test, or something like this. And this event trigger yet another workflow with issue comment trigger. And this workflow will have access to secrets and credential. In the second privileged workflow, you can build product, you can consume some credential, you can implement some additional end-to-end tests to make sure that this contribution is OK. And then accept this pull request and merge this into your repository. So the main idea, so one of the typical cases when you may use this IssueOps approach is when you process pull request from fork. So let's check what may go wrong from security perspective. This is a very lightweight threat model. What may go wrong? So from attacker perspective, some goals from attacker perspective is, of course, exfiltrate your secrets and long-lived credentials, like if you use some API keys or tokens to access your LLM or registry. This is an example. Other objective is to get access to your GitHub token with the right permission, because if you have GitHub token with the right permissions, you can change the state of repository. You can commit some malicious code, you can create release, you can create tag, and something like this. And last but not least is, we can call it the denial of wallet attack. For example, if your workflow consumes some non-free of charge API, like, I don't know, LLM to provide code review, or for example, if your repository contains some documentation and on pull request you would like to take the documentation, for example, in English and translate it into several languages just to make sure that it is okay, and for this purpose you use some LLM, then if attacker is able to launch your privileged workflow and consume this LLM, it will be uncontrolled consumption and it will cause some issues. So the main idea here that technically what attacker would like to do remote code execution. Attacker would like to put some execution code into his or her contribution and ask workflow to execute this code. So injection point in this example, if you take a look on workflow number 2, there is a line like /ci/build sh. This is, for example, your code that built your product. And if attacker is able to make a fork, put in this shell some lines of code that will read your environment variables and exfiltrate it, this is exactly what attacker would like to do. This is something remote code execution. So let's take a look on some basic stuff and some typical attack scenario and typical mitigation. The first thing is that this approach is based on putting some comments, and you know that in available public repository, everybody with a GitHub account is able to put comment on issue, on pull request. So in this attack scenario, attacker prepares some malicious pull request with some malicious code in this build sh that will read environment variable and send it back to attacker environment. And then on step number 2, attacker put some specific comment like run tests, and it will trigger this privileged workflow. So we can call it broken access control. To mitigate it, some obvious mitigation is to just check that actor who made this comment is actually contributor, or not contributor, but collaborator or member of this repository. So it means that you will trigger this workflow only if this comment was created by some member of your repository. This is some kind of access control check. Another interesting attack pattern, this abbreviation is time of check, time of use attack. And this attack relates with the fact that when you use GitHub hosted runners, technically GitHub hosted runners is a virtual machine that provided to you by GitHub. So when you trigger workflow, it takes some time from this event to the event when GitHub allocate you runner and start this workflow will run. So it means that attacker have some window of opportunity to inject yet another malicious commit. So I mean, the main point is that there is a gap between event of, for example, comment or pull request and the fact that virtual machine is allocated and job under these GitHub actions are started to execute. So, and attacker is able to use this opportunity to insert yet another malicious commit. In this scenario, and at the first stage, attacker prepares some legitimate pull request with some good things. Then this pull request is passed through this workflow number 1, pass all necessary checks, maintainer put some specific comments like OK to test, but then because there is some gap between comment and the event when this workflow will be launched, attacker is able to make yet another commit to pull request, and when workflow number 2 will check out code, the job will check out code with some malicious commit. And this is what's called time of check, time of use attack. So to mitigate this, there are several patterns. One pattern is that I saw in the wild that you need to check the timestamps, timestamp of comment and timestamp of the last commit in this pull request. So you can consume GitHub API, check some information about pull request, and if comment was before the last push on this pull request, then obviously this is some bad pattern. This approach is very fragile because in general you depend on GitHub API, you depend on JSON that GitHub sent you in a response. If for some reason you make some mistake in this code, like you have some misspelling in this name of this JSON key, or GitHub will change their contract, this mitigation will not work. So if you will use it, you need to use it very carefully. The most straightforward approach is just ask contributor, maintainer to put commit. So there is a contribution on the step number 2. Maintainer can review this workflow number 1, all commits and pull requests, and say, okay, I review exactly this commit. Let's use exactly this commit to execute privileged workflow. In this case, even if attackers can insert yet another commit because you hard-code this SHA commit in your comment, you will check out code. You will check out some trusted code that was reviewed by maintainer, and this approach is more robust. And last but not least, you may not use comments, but you can use labels. Like you open contributor open pull request, and if this pull request is okay to do some additional task, like this workflow number 2 with end-to-end test, you put some specific label on this pull request, like okay to test or something like this. The key point is that assign some label is operation that is allowed only for a privileged user, and also when you use this event like pull request target with types label it, in the context of this event you already have the commit SHA of this pull request. So if you use this SHA, even if attacker will put some additional commit on the top of this pull request, anyway you will check out code that was reviewed and checked by maintainer in the step number 2. So this is also one of the potential mitigation. And this is the last slide, and key takeaways. I think the main takeaway is that you should treat your CI/CD pipeline, especially if you operate in open source, as one of the critical assets in your product. Because your product may be very sophisticated with a lot of design patterns, with a lot of API interfaces, and it may take some time for an attacker or attacker with LLM to understand what's going on in your product. But in contrast, your CI pipeline is very easy because you use some well-known patterns, you use some common practice that's adopted by industry, but also your pipeline have access to your secrets, to your infrastructure if you use some self-hosted runner, for example. And the main point is that it is better to apply all practice that you usually apply for product also to secure your CI pipeline, like threat modeling, static code analysis with ScottQL or Zismore that was already mentioned on the yesterday talk. If you can, you also may make some security testing just to check that behavior of your workflow is okay. Yeah, that's it. Thank you very much.